Myself, Mahesh Chitmalwa, Associate Professor, Saraswati Institute of Pharmacy, Kurtadi. Today's lecture on Micromeritics. Okay, so what do you mean by Micromeritics? What is the importance of Micromeritics? Okay, why study about Micromeritics in pharmaceutics? Hmm? Whatever questions, resolve the question questionnaires about Micromeritics. So let us discussion on Micromeritics. First of all, what is meant by Micromeritics? Micromeritics is the science and technology of small particles. Micro means small and meritics means measurement. Number of raw materials are required for the finished good material, for the preparation of finished good material. Thus materials APIs raw materials are micro micronized particles. So this particles measurement is necessary for the preparation of number of dosage form such as ointment, tablet, liquid, whatever ORS. Okay. So the micrometrics is the science and technology of small particles. The micrometrics, the unit of particle size used in the micrometer, that is denoted by micron. So the applications in pharmacy of micrometrics, release and dissolution, it's very important factor related to the powder form, absorption and drugs action, physical stability, dose uniformity, number of applications used in the any preparations. The powders are size and size range is necessary importance for the pre-formulation study of the any fine amorphous crystalline powder the micro or micronization. The size and the size range of particles are important in pharmacy because the size and surface area of a particle related to the physical, chemical and pharmacological properties of drug. The size and size range of particles is important. The measurement of size, measurement of surface area of particle related to the physical and chemical pharmacologic properties of a drug. The particle size of a drug can affect its release from dosage form that are administered orally, parenterally, rectally, and topically. In the area of tablet and capsule manufacturing, the control of the particle size is essential in the necessary flow properties and proper mixing of granules and powders. In the area of tablet capsule manufacturing, control the particle size is essential, necessary flow properties, proper mixing of granules and powders for the preparation of tablet and capsule. Particle size and size distribution is necessary in the collection of particles of more than one size. Any raw material are collected and particle size of more than one size. Two properties are important. First one is the shape and surface area of the individual particle. The, the particle size and size distributions is very necessary for the preparation of any dosage form. What do you mean by particle size and what is the measurement skills are developed in the pharmaceutics? The size of the sphere is readily expressed in terms of its diameter. The size of sphere is readily expressed in the terms of its diameter. The surface diameter denoted by ds is the diameter of sphere having the same surface area as the particle. The volume of diameter dV denoted by dV is the diameter of a sphere having the same volume as the particle. The projected diameter, that is the denoted by dP, is the projected diameter of a sphere having the same observed area as the particle. The Stokes diameter, denoted by dSt, is the diameter which describes an equivalent sphere undergoing sedimentation at the same rate as the same asymmetric particle. Particle size and collection of particles is usually polydisperse. It is therefore necessary to know the size of the certain particles, but also how many particles of the same size exist in the sample. We need an estimate of the size range present and the number of weight fraction of each particle size. This is the most important particle size distribution, and from it we can calculate an average particle size for the sample. Particle size distribution, when number of weight of particles lying within a certain size range is plotted against the size range or mean particle size, a so-called frequency distribution curve is obtained. This is important because it is possible to have two samples with the same average diameter but different distributions. The mean particle size is important thing. The mean value of particle size is distribution. The value of each particle size should be multiplied by the normalized particle amount, and the result should be divided by the total normalized particle amount. So in the micromeritics unit, properties of powders is very important thing. The first property is their fundamental properties, and second property is derived properties. This property related to the individual particles. The first one is the explain about fundamental properties. Fundamental properties is number of in which number of parameters. First one is particle size and size distribution, particle shape, particle surface area, particle weight. In the fundamental properties, particle size and size distribution, particle shape, particle surface area, and particle weight. In derived properties, first one is the density of powder. In the density of powder, bulk density, tapped density, granular density, and true density. In the derived properties, most important are flow properties of powder, porosity, bulkiness. These are the derived properties of micromeritics. First one is the fundamental properties of powder. Explain about particle size. The particle size denoted in micromeritics, denoted in micrometers. 1 micrometer is equal to 10 to 3 mm or 10 to 6 mm. 1 milli micrometer is called 1 nanometer. 1 micron is equal to 1000 mm. 1 mm is equal to 1000 micron, and 1 micron is equal to 1000 nm. That is the nanometer. Particle size determination methods for the use of different methods: optical microscopy, sieving method, sedimentation method, conductivity method. The optical microscopy, that is the range of particle size 0.2 micron to 100 micron. In sieving method, range of particle size 40 to 9500 micron. In the sedimentation method, the range of particle size 0.08 to 300 micron. In the conductivity method, range 0.5 to 300 micron. Explain about, first of all, optical microscopy, that is the fundamental property. In the optical microscopy, the particle size in the range of 0.2 to 100 micron can be measured. This method gives the number of distribution which can be converted to weight distribution. Optical microscope lens has limited resolving power. Advanced microscopes have better resolving power and can measure size in nano range. That is ultra microscope, electron microscope, scanning electron microscope, transmission electron microscope. What is the procedure follow the optical microscopy? Eyepiece of the microscope is fitted with the micrometer. This eyepiece micrometer is calibrated using a standard stage micrometer. The powder sample is dispersed in a suitable vehicle in which it does not dissolve and its properties are not altered. Example, water, paraffin oil. This sample is mounted on a slide and placed on the stage under the objective of microscope. Around 625 particles are visualized. Their diameter is noted and mean is computed. Advantages of optical microscopy: can view particles, any aggregates detected, contamination of particles detected, use of cover slip for arresting motion of particles, easy and simple method. Most important advantages is there. Disadvantages: length and breadth can be detected but depth or thickness of particles cannot be measured. What is the disadvantages? Length and breadth can be detected but depth or thickness of particles cannot be measured. Slow, time consuming, tedious, inaccurate. Number of particles to be measured is more sample required. Most important applications: optical microscopy, particle size analysis in suspensions, aerosols, globule size analysis in the emulsion. That is the applications. Once again, particle size analysis in suspension, aerosols, globule size analysis in emulsion. Sieving method. Sieving method is an ordinary and simple method. It is widely used as a method for the particle size analysis. Sieve analysis is usually carried out using dry powders, although for powders in liquid suspension or which agglomerate during dry sieving, a process of wet sieving can be used. In the sieving method directly gives weight distribution. It find application in dosage form, development of tablet and capsule. Normally, 15% of fine powder should be present in granulated material to get proper flow of material and achieve good compaction. Thus, presence of coarse, moderate, fine powder is estimated by this method. What is the procedure followed for the distribution of method? Sieve analysis utilize a wire mesh made up of brass, bronze or stainless steel with the known aperture, that is the hole. Diameters which form a physical barrier to particles. The standard sieve sizes are as per the pharmacopoeia. Most sieves analysis utilize a series stack layer of sieves which have the coarser mesh at the top of the series and smallest mesh at the bottom above a collector tray. Operational principles is most important thing. A sieve stack usually comprises 6 to 8 sieves. Powder is loaded onto the coarsest sieve on the stack and then it is subjected to mechanical vibration for specified time, example 20 minutes. After this time, the powder retained on each sieve is wetted. The particles are considered to be retained on the sieve mesh with an aperture corresponding to the sieve diameter. The size is estimated as per the standards given in pharmacopoeia. Care should be taken to get reproducible results. The type of motion, time of operation, speed, weight of powder should be fixed and standardized. Advantages: this method is advantageous, inexpensive, simple, rapid and reproducible results. This method disadvantages: distribution methods. Disadvantages: lower limit is 15 microns, powder is moist, can cause clogging of apertures. Attrition between particles during the process may cause size reduction, giving inaccurate results. Next method is sedimentation method. In this method, the size can be determined by examining the powder as it is sediments out. In the sedimentation method, the particle size range in between 0.08 to 300 micron. Several methods has based on the sedimentation such as pipette method, balance method, hygrometers method. By measuring the terminal settling velocity of particles through a liquid medium in gravitational centrifugal environment using by Anderson apparatus. Principle of sedimentation method. Particle size analysis by sedimentation method can be divided into two main categories according to the method of measurement used. Measurement of particle in retention zone and non-retention measurement zone. An example of non-retention zone measurement is known as the pipette method. Anderson pipette method. One of the most popular of the pipette method was that developed developed most popular of the pipette method was that developed by Anderson and Lundberg and commonly called as the Anderson pipette. In this method, in this method, Known volumes of suspensions are drawn of and concentration differences are measured with respect to. In this method, known volumes of suspensions are drawn of and the concentration differences are measured with respect to time. It involves measuring the percentage of solids that settle with time in graduated vessel. Sample preparation: powder is dispersed in a suitable solvent. If the powder is hydrophobic, it may be necessary to add dispersing agent to aid wetting of the powder. In case where the powder is soluble in water, it will be necessary to use non-aqueous liquids or carry out the analysis in the gas. In Anderson pipette construction, the Anderson fixed position pipette consists of 200 graduated cylinder which can hold about 500 of suspension fluid. A pipette is located centrally in the cylinder and is held in position by a ground glass stopper so that its tip coincides with the zero level. A three-way tap allows fluid to be drawn into a 10 reservoir which can then be emptied into a beaker or centrifuge tube. Which method follows this method? A 1% suspension of the powder in a suitable liquid medium is placed in the pipette at a given interval of time. Samples are withdrawn from a specified depth without disturbing the suspension. The amount of powder can be determined by weight following drying or centrifuge. Alternatively, chemical analysis of the particles can be carried out. A pipette is located centrally in the cylinder and is held in position by a ground glass stopper so that its tip coincides with the zero level. A three-wave tap allows fluid to be drawn into a 10 reservoir, which can then be emptied into a beaker or centrifuge use. The amount of powder can be determined by weight following drying or centrifuging. The data of cumulative weight is used for the determination of particle weight distribution, number distribution. Next method is the conductivity method. Electrical systems seasoning zone method, that is the counter method. Powder samples are dispersed in a electrolyte to form a very dilute suspension. The suspension is usually subjected to ultrasonic agitation to break up any particle agglomerates. Conductivity method is the measurement of conductance by the counter method. A dispersion may also be added to aid particles de-agglomeration. The particle suspension is drawn through an aperture accurately drilled through a sphere crystal set into the wall of a hollow glass tube. Electrodes situated on either side of the aperture are surrounded by an electrolyte solution. These electrodes monitor the change in electrical signal which occur when a particle momentarily occupies the orifice and displays its own volume of electrolyte. The volume of electrolyte fluid which is displaced in the orifice by the presence of particle causes changes in the electrical resistance between the electrodes, which is the proportional to the volume of the particle. Counter method, number of advantages. First one is the particle size ranging from zero point 0.5 to 500 micron. Second is gives number of distribution particle volume measured and can be converted to diameter. Accurate, sensitive, fast technique. 4,000 particles per second can be counted. 4,000 particles per second can be counted. And this method disadvantage mostly is expensive. This method is the expensive. Lesser light scattering methods. It is based on the principle of change in light intensity. The measurement of this change in light intensity gives estimate of particle size. Next one is the surface area measurement, surface area determination. How it is surface area determination? First of all, explain about surface area. Surface area of a powder can be calculated using particle size data obtained from any suitable method. Specific surface area, that is the surface area per unit weight. Surface area denoted by SV. Surface area is an important parameter as the viability of certain drugs is dependent on the surface area. Surface area is the important parameter as the viability of certain drugs is dependent on the surface area. Example of surface area is the drugs griseofulvin, that is the antifungal drug. If the surface area is less than specified, the absorption decreases. Second example is the anti-helminthic drugs such as bifenthrin, bifenium. How to surface area determination? How to surface area determination? Adsorption method. Surface area is most commonly determined based on Bernard-Imitate-Taylor, that is the BET theory of adsorption. Most substances adsorb monomolecular layer of gas under certain conditions of partial pressure of gas and temperature. The adsorption process is carried out at liquid nitrogen temperature. Once surface area adsorption has reached equilibrium, the sample is heated at RT and nitrogen gas is deabsorbed, its volume is measured. In each fixed area, one can compute surface area of pre-wetted sample. Surface area measurement methods is the first one is the adsorption and second one is the air permeability method. In the air permeability method, powder is packed in a sample holder. Packing appears as series of capillaries. Air is allowed to pass through the capillaries at constant pressure. Resistance is created as air passes through capillaries such as causing the pressure drop. Air permeability is inversely proportional to the surface area. Particle size, how to determine surface area. In the particle size weighing distribution method, surface area air permeability method, adsorption method, and number of techniques, particle size, particle shape, and surface area determination methods. Explain in next lecture.